So this is part 3 of CUTSIE WHUN and VISUINO. This one is CUTSIE WHUN R.O.C, your rate of change. Now, the first thing we did is get your gyro and all that set up. The second part was this section here, and that was getting your center of balance, getting your subtract value, and all that to find the balance of your robot. Now this part is your rate of change. Your rate of change is what the Kalman filter needs to adjust the speed of your motors. So the faster your robot is tipping, the faster your motors turn to stand your robot back up, straight, and down. Now one thing that about this that is kind of neat is you can set the GForce. So you've got 2, 4, 8, and 16G. 16G being the least sensitive. So it's 16 times the force of gravity per point, if you want to think of it that way. Besides 2 times the 2 times the gravity to each point. You're getting 16, so you're way less on the here, let me show you something here. Now this is the gyro coming out of CUTSIE WHUN. Now if you notice, the red line is the center of balance line. It's sitting right around 0.5, and the blue line is the rate of change. So the faster, when I tip CUTSIE WHUN faster, you know, the red line here actually changes and adjusts itself according to how far the pitch is, kind of like a heartbeat. You know, I can hit it like this and it does not change the motor speed that much. But if I do this and tip the robot back and forth, then it's also taking the input from the gyro along with the rate of change and changing it. This is tipping the forward, backward. You see the red line moving, and this is banging on the table, making the accelerometer bump, but the red line is not changing for the motors. This is tipping, that's banging. You see the difference? Big difference. All right, now one other thing with all this is you have to get your values correct with your subtractions. So find them. Go back and find the COB, CUTSIE WHUN COB, center of balance, and double it. You do it on the accelerometer X and the gyroscope X. The gyroscope is for your speed change meter, and you will find this by typing speed change in the component list. And then from there, it feeds into the Kalman filter. And the Kalman filter is the part that has your proportional, integral, and derivative numbers that actually tell the robot how fast, and it smooths it out really nice. So that is basically how it is put together. I will get this zipped up and set in with the posting. Thank you for watching.